The Coast Guard Search and Rescue Visual Analytics is a collaborative project with the U.S. Coast Guard's 9th District and Atlantic Commands, who are in charge of the Great Lakes area. This project intends to analyze historic response operations. By using interactive menus, we are able to select the distress types we are interested in visualizing. In this case, we choose to visualize all search and rescue cases. The Time Slider widget is used to temporally scroll through the data while dynamically updating all other linked windows. There are several temporal aggregation methods for the data, such as daily, weekly, monthly, yearly, and a user-customized one. We can start by analyzing the data on a monthly basis. The time series display allows us to visualize the yearly trends. The graph is currently separated by Coast Guard Captain of the Port, COTP, zones, but we can aggregate it to see overall trends. As you can see, the peak of the operations is during the summer months, which is expected since winters can be harsh and most of the lakes freeze. We are now interested in locating the specific month where the peak appears. The slider indicates that the peak is located during July, month 7. We use the calendar view to provide more insight about these trends. There are histograms for each row and column, which allow the analysts to visualize weekday and weekly trends of incidents. This information is useful in determining an effective resource allocation scheme. Following our previous discovery about July being the busiest month, we can see the majority of the incidents occurred during the weekend, and we also notice that the busiest week of the year is around 4th of July, USA's Independence Day. However, we also notice 2 other weeks that have a high number of incidents. Finally, we have modified the view to support an interactive database querying method for acquiring summary statistics from the database. Along with the time series display and the calendar view, the program also features a clock view, which allows us to analyze the time of the incidents based on the aggregation we were previously using. For example, for the month of July 2010, most of the incidents occurred at 4 p.m. In the map, we can visualize the different stations and their boating hour densities. Each point in the map represents an incident, and we can quickly identify hotspots by using density estimated heat maps. Furthermore, we can turn on a heat map showing the time taken, in minutes, by the Coast Guard stations to deploy an asset to the Great Lakes to respond to a SAR incident, assuming a speed of 15 nautical miles per hour.